Okay, so number 9, so we've got vectors. So the position vectors of A and B are these. Remember, position vectors are always based from the origin. So say A was here, B was here. This is the vector from O to A, and this is the vector from O to B. So if you want to find A to B, you're going back to the origin, so in other words, negative A, but negative 3, negative 2, 2, and then you're going positive direction from B, so 6, 4, negative 1. So that's positive 3 plus 6 is 9, positive 2 plus 4 is 6, and negative 2 plus negative 1 is negative 3. Point C also lies on L such that AC equals 2 lots of CB. So, from A to C is equal to 2 lots of C to B. I'm running out of space. Okay, let me go down here. Oh, God, marvelous. Okay, so A to C is equal to 2 lots of, I forgot what it was already, C to B. So, well, let's imagine that vector C is X, Y, Z, position vector for C. In other words, O to C. So from A to C would be minus A, so that's 3 to negative 2, plus X, Y, Z, and that should be equal to 2 lots of negative X, negative Y, negative Z, plus, this should be a big bracket, plus B, which is 6, 4, negative 1. Alright, so 3 plus X has to equal negative 2X plus 12, because it's 2 lots of everything in this bracket. 2 plus Y has to equal negative 2Y plus 8, negative 2 plus Z, so they look too similar, equals negative 2Z minus 2. Alright, so we just need to solve these things. Oh. So 3x equals 9, so x equals 3, 3y equals 6, so y equals 2, and 3z equals 0, so z is 0. So there we go, we've shown that it's 3, 2, 0, which is what we were asked to do. There are other options, but I suggest that was probably one of the easiest things to do. Alright, so let theta be the angle between AB and OC. Find theta. So we've got AB and we've got OC. So 9, 6, negative 3. And 3, 2, 0. So we know that cos theta is the modulus of those two things, so A, B, and OC over the what am I talking about? The dot product AB dot OC over the modulus of AB modulus OC. What are they called? AB and OC. So cos theta equals so the dot product, remember, you multiply each of the terms and add them. So that's 27 plus 12, and the modulus of them is the square root of 9 squared plus 6 squared plus negative 3 squared. So 81 plus 36 plus 9. 90 is 126. And for this one, it would be 2 plus 2 squared, so it's 9 plus 4, so it's root 13. 39 over root 126 root 13. So theta is cos to the minus 1 of the answer. And it doesn't really matter what. So let's change our calculator to degrees. Okay, so shift cos that's 39 over root 126 multiplied by root 13 gives us 15.5 degrees. Okay, so let D be a point such that OD is K, where K, ooh, well, let me check the time. Okay, right, so it looks super confusing, but it's actually not too bad. You just have to know what to look for. Easier said than done. So we've seen that this is talking about sine theta. The fact that they've drawn this diagram here and shown that this is theta, hopefully you remember vertically opposite angles would mean that this angle would also be equal to theta. They're talking about length of DE, so they're talking about this length here. So this is length DE. And hopefully you remember your SOHCAHTOA in that sine theta would be length DE divided by length CD. Okay, so that's an expression that we're missing, this length CD. Now we do know, okay, so let me write this down here. Whoa. Okay, so we've got, so length, so sine theta is length DE over length CD. Okay, so now we need an expression for CD. So we go back up to here, and we can see that C to D would be O to D subtract O to C. Well, hopefully you can see that. So O to D subtract O to C. So it's O to D subtract O to C. Well, we know that O to D from the question here is K from OC. So O to D is K OC. So we would write CD is K OC minus OC. So C to D would be K minus 1 OC. Great, all I've done is factorize because I've got OC common here and here. So I brought out common factor of OC, which gives us K minus 1. Right, so let's go back to this expression here. Oops. So sine theta is DE divided by k minus 1 OC, and just rearranging that gives us DE is k minus 1 OC times by sine theta, which I believe is what they asked us to show. Okay, the distance from D to L is less than 3 units. Oh, find possible values of k. So from D to L is less than 3 units.